Okay, so if you can turn to page 12 of your packet, what we're going to do today is we're going to be given pictures of trig graphs, and from those pictures, we're going to come up with the equation. Now, there's a couple formulas that I have right here that we're going to use over and over again. And there's a couple definitions right here that we're going to use over and over again. So what I'd like you to do is take 2 minutes hit pause. And I'd like you to copy this down onto number 21 and copy the definitions down next to number 21. And then also, if you can turn to the back of your packet, it's a blank page. If you could also put these formulas and definitions on the back of your packet, that way you don't forget them, that would be great. All right, after you do that, you can hit play again. All right, so number 21 says, the following function can be modeled by the equation y equals a sine bx plus c. Determine the values of a, b, and c and explain how you arrived at your values. Okay, so if we look at this equation, right, we know that A stands for the amp. I'm just going to kind of label this. So A stands for the amp. Okay, we know that B represents the frequency. This equation doesn't have a horizontal shift, or else it would be in the parentheses with the x. And then the C here represents our vertical shift. So I'm just going to kind of abbreviate all this. All right, so they just want us to compute these values and, just, I guess, when it says explain how you arrived at your solutions, you can, with these types of problems, you can explain through the work if you want. All right, so let's start with the A, the amplitude. So amp. Now, you can tell by looking at this graph if you'd like. We know the definition of amplitude is the distance from the midline. So here's the middle of your graph, right? At 1, if this goes up to a height of 2, and the minimum is at 0, halfway between 2 and 0 would be 1. So this is the midline. So the amplitude is 1. It's the distance from the midline. It goes up 1 unit from the midline. It also goes down 1 unit from the midline. Okay, now what I'd like us to do in addition to that, or instead of that, is I'd like us to use the formula. It just really ensures that you're definitely going to get the right answer. So if we use the formula for amplitude, we could see amplitude is equal to, okay, it says it right here, max minus min divided by 2. So let me write that out. Max minus min divided by 2. And this is kind of my explanation of what I'm doing. All right, so the maximum we could see is at a height of 2. The minimum we could see is at a height of 0, so let's plug those in. And if we subtract those and divide by 2, well, 2 minus 0 is 2, and 2 divided by 2 is 1. So let me just make like an answer box here. So in the answer box, they wanted us to find A, B, and C. So A, amplitude, is equal to 1. All right, so now we have to find B, and we have to find C. Okay, so we can, again, just visually do each of these, or we can use our formulas. Now, if we want to visually find the frequency, we know that the frequency is the number of cycles between 0 and 2 pi. So here's 0 and here's 2 pi. Okay, between 0 and 2 pi, we're only fitting half of a sine curve. So, if you want to write out the frequency, you know what, let me do this. Let me color coordinate this. So we're going to make the frequency is equal to 1/2. You could just write that, and you could put for your work, there's a half of a cycle between 0 and 2 pi. Okay, that would be enough for your work. Or, so let me just put B as 1/2 in here. Or if you wanted to use this formula right here for frequency, okay, I'll do it off to the side here. So frequency is equal to 2 pi over the period. Okay, so that's equal to 2 pi over. Now the period is the horizontal length of one cycle. So this right here is one complete sine curve. So horizontally, it took us 4 pi units to get there. So I'm going to replace period with 4 pi. And then if you simplify this, the pi's cancel off, and 2 divided by 4 is 1/2. So either way, we get 1/2 as our answer. Okay, so you could see right off the bat, you can do these visually, and you can use your formulas. All right, the last thing we're going to use is we're going to find the vertical shift, which is C. So let me see, vertical shift. I mean, the vertical shift is always equal to your midline. So if you wanted to visually look at it, you could see that the midline, the middle height of the graph right here, is at 1. So if you just want to say, all right, there we go, 1. But you do have to explain how you got that. I think the easiest way to explain it is just to use the formula. The formula is maximum minus amplitude. Okay, that's how we found the vertical shift. So if we take the max, which is 2, and subtract off the amplitude, which is 1, we will wind up getting 1. Okay, so let's write that out. So vertical shift is equal to max minus amp. So the max is 2, that's the highest point on the graph. The amplitude we already found, which was 1, and if you subtract those, you get 1. So there's our values for A, B, and C. Okay, now if you read number 22, I mean, it really says the same exact thing. The only difference between this and the last one is now we have a horizontal shift in here, right? It says minus C. So I'm going to kind of color code this again. All right, so we'll have the amp. A represents the amp. Okay, that's in red. B, again, is our frequency. Okay, frequency is what's in front of the X. And in this case, we have an X minus a horizontal shift in the parentheses. I'm going to make my horizontal shift. I'm just going to write HS. That'll be in black. And then the vertical shift is the D at the end by itself. That's going to be in green. Okay, so anyway, again, the amp is in front of the word sine or cosine. Frequency is in front of the X. Whatever's being really added or subtracted in the parentheses with the X is your horizontal shift. And whatever's being added or subtracted from the end is your vertical shift. Now, I just want to remind you, if there's a minus sign, if it's X minus some value, you're shifting to the right. If it's X plus some value, you're shifting to the left. Whereas out here, a positive, a plus sign, shifts you up, and a negative sign shifts you down. Okay, now one thing I want to point out, this is really important. This curve, if you look back up at number 21, it is the same exact curve. Okay, same exact curve. So this is the same thing as the graph above, and what they want us to do is they want us to write this instead of as a sine curve, they want us to write it as a cosine curve. Okay, so hit pause if you have to, but I'd like you to copy this down. This is really important. It says this is the same curve as above. Any sine function can also be written as a cosine function. And you'll see as we do this that the amplitude, frequency, and vertical shift will be the same. The only thing that changes when you convert from a sine curve to a cosine curve is the horizontal shift. Okay, so let's do this. We have to find A, B, C, and D. So let's start off with A. So we know A is the amplitude. I'm going to just use my formulas here, and then we could look at the graph. So A equals max minus min divided by 2. Now, you'll see it's the same curve. So the max is still 2. The minimum height is still 0. And when we divide that by 2, we still get an amp of 1. Okay, so the amplitude is equal to 1. Okay, the frequency. So the frequency, which we're calling B, is the number of complete curves between 0 and 2 pi. So you can see between 0 and 2 pi. Now, it's a little harder to see because if we're looking at a cosine curve starts high and drops down low and then usually comes right back up high again. Now, instead of looking at it between 0 and 2 pi, let's look at it in a span of 2 pi units. So if you go from pi to 3 pi, haven't you progressed from pi to 2 pi as pi? And then you progress another pi, so you go 1 pi, 2 pi. So I'm going to look from here to here. So in a span of 2 pi units, we've only completed half of our cosine curve. So the frequency is 1/2. Okay, so B equals 1/2. If you want to show work for that, you could either put that in sentences, there's a half a cycle between 0 and 2 pi, or you can say the frequency is equal to 2 pi over the period. And we know the period is how long it takes to complete a cycle. So it's the horizontal length of one cycle. So horizontally, let's think about it. If we went from the top of a cosine curve all the way over to the next top, right? You're starting from pi, and you're going down and down. We hit the very minimum at 3 pi. We start going back up at 4 pi, and once we hit 5 pi, that's when we would complete the full cycle. So to get from 1 pi to 5 pi, we've gone 4 pi units. So I'm going to put 4 pi here. And then this simplifies to 1/2. Or again, if it's easier for you, you can just say the frequency is how many complete cycles in a span of 2 pi units. Okay, the next thing we're going to look at here is the horizontal shift, and the last example didn't have that, so that's C. The horizontal shift, you just want to figure out how far did you have to shift to either the left or the right to, come to the beginning of a cosine curve. So since a cosine curve starts high, I'm looking at this right here as the beginning point of a cosine curve. And I mean, if you kept this curve going, this curve would continue to go and go. 5 pi would be the next beginning spot. And then you would just keep going. There'd be lots of spots that, start a cosine curve. But I'm going to use this one here because this is the most apparent. I'm going to say my horizontal shift is right here. Now I just totally covered it, but this under here said pi. So we shifted pi units to the right to be at the beginning of a cosine curve. So C, the horizontal shift, is equal to pi. And for my explanation, I'm just going to say pi units to the right. That's how far we had to shift to the right to start. Okay, and then finally we want to find D, which is your vertical shift. So if we use our formula, we know that vertical shift is equal to the max minus the amp. And you can see your maximum here is 2. And the amp we already found to be 1. So 2 minus 1 is 1. So D equals 1. Okay, D is the vertical shift, which is basically where you can find your midline. Okay, how far we shifted up to find the midline of this graph, so 1 unit. Okay, if you can turn to number 25, that's on page 14. It says the times of average monthly sunrise, as shown in the accompanying diagram, over the course of a 12-month interval can be modeled by this equation. Determine the values of A, B, and D, and explain how you arrived at your values. All right, so this is really the same deal as the other ones. We know that A represents our amplitude. We know that B represents the frequency. Sorry, that's a little off. And then we don't have a horizontal shift because there's nothing in the parentheses with the x, and being subtracted from the x, I should say. And then D is your vertical shift. Okay, now this graph is a little different if you look, because the x-axis, instead of it being in terms of pi, it's in terms of numbers. So, I mean, really that's all that's going to affect is our frequency. But, all right, so let's see. So A, the amplitude. We're going to use our equation that we've been using. So amp is equal to max minus min divided by 2. Okay, so we could see the maximum is up here, which has a height of 8, okay? And the minimum is 5. So we'll do 8 minus 5 divided by 2. So 8 minus 5 is 3, and 3 divided by 2 is, you could write it as either 3/2 or 1.5. I'm going to write 1.5. Either way is fine, though. So amplitude is 1.5. Okay, now the frequency. This is where it's a little different. So the frequency, you know what? I'm going to use our formula. Frequency is equal to 2 pi over the period. Because when the x-axis is in terms of numbers, you can't just look and say, all right, how many complete curves fit, in a span of 2 pi units, because this isn't labeled in terms of pi. But we could totally use this formula. Frequency is 2 pi divided by the period. So the period is the horizontal length of one complete cycle. So one complete cycle, let's see, if this curve, I'm going to continue this curve a little bit. If this were to continue, right, since we know that the maximum here is 8, this would continue up to 8. Let's see. So the period is the horizontal length of one complete cycle, which would be 12 months. Okay, so I'm going to replace the period with a 12. So we have 2 pi over 12. And then since 2 over 12 is 1/6, this would simplify to pi over 6. So when your x-axis is in terms of numbers, the frequency is in terms of pi. All right, so let's write b equals pi over 6. Okay, and then finally your vertical shift. I kind of mixed and matched these colors here, so, okay, either way, but the vertical shift, we're going to use the same formula we've been using. It's just equal to the max minus the amp. So the maximum height the maximum point this graph reaches has a height of 8. And if we subtract out the amp of 1.5, that'll tell us our vertical shift is at 6.5. Okay, so C equals 6.5. All right, so there we go. Now, one thing I want to point out, if they ask you to write the equation of the curve, what they want you to do is they want you to take these values and substitute it back into the equation. So if we had to write the equation, we would write y equals 1.5 times cosine of pi over 6x plus 6.5. Okay, so you just take it and plug it in. Okay, so there's 2 more questions, multiple choice questions, that I'd like you to first try on your own, and then you can hit play, and I'll go over it and you can see how you did. The first one that you're going to try on your own is number 29. And then after that, the next one you're going to try on your own is number 36. And then after that, you could just hit play and see how you did. Okay, number 29 says, the voltage used by most households can be modeled by a sine function. The maximum voltage is 120 volts, and there are 60 cycles every second. Okay, I'm going to underline that. That's important. 60 cycles every second. So what that means is if there's 60 cycles every second, let me just draw that out. So let's just say we had, here's 0 seconds and here's 1 second. If there's 60 cycles every second, it means you're fitting 1, 2, 3, 4, 5, and so on. You're fitting 60 curves between 0 and 1. So if you're fitting 60 curves between 0 and 1, what that means is the horizontal length of one of these curves would be 1/60th of a second. Okay, so let me just write that out. So if the length of one cycle is 1/60th. So what that means is if you're fitting 60 cycles in 1 second, the length of one of those cycles would be 1/60th of a second. So if the length of one cycle is 1/60th, well, this is another way of saying the period, right? The period is the horizontal length of one cycle. So we know the period is 1/60th. Okay, so if we look through these answer choices, you could see that all of these have an amp of 120, so they don't differ there. But here, this has a frequency of 1, a frequency of 60, a frequency of 60 pi, and a frequency of 120 pi. Well, if we know the period, right, we know that frequency is equal to 2 pi divided by period. Oops, that's a Q. So if we take 2 pi and divide it by the period right here of 1/60th, okay, so 2, I'm going to kind of disregard the pi for right now. 2 divided by 1/60th, if you did keep, change to multiplication, and flip this upside down, is the same thing as 2 times 60. So 2 times 60 is 120, and we still have a pi there. So the frequency is 120 pi. So if we look here, choice 4 is the one that has the frequency of 120 pi, so that's the answer. That one was tricky. Okay, so number 36 wants to know, as x increases from 0 to pi over 2, what will happen to the graph of the equation y equals 2 tan of x? Now, we haven't looked at the graph of tan of x, so I wasn't sure what you guys were going to do with this. But, honestly, I thought the easiest way to do it was just in your calculator to just go to y equals and type in 2 tan of x. And then if they want to know what happens between 0 and pi over 2, you can just set your x minimum to 0 and your x maximum to pi over 2 and look at the graph and see what's happening. All right, so that's what I did here. Here's my graph. And you could see I adjusted the window, right? There's the x min is 0, and this x max I set to pi over 2. And the y I didn't even adjust. This is just -10, and this goes up to +10. So if we want to see what happens as we increase from 0 to pi over 2, what's happening is your graph is increasing, and it looks like it's going to go up and up and up and up and up. So let's say increase from 0 to 2. Well, no, it's definitely going much higher than 2, so that's not the answer. Choice 2, I see the word decrease. That's not happening. Choice 4, I see the word decrease. That's not happening. So choice 3, increase without limit. That's right. It's going to continue to increase and increase all the way up to positive infinity. So choice 3 is the answer.